Hello, and welcome to the first episode of the Code Breakdown. This is going to be the first of a series primarily focused on BDD and testing inside of BDD. So let's get started. So this is really just kind of a short, hopefully around 10-minute screencast to give you a high-level overview of BDD, what its core principles are, how it's valuable, kind of how it relates to a test stack, the tools that it provides, and the general BDD cycle. So what is BDD exactly? Well, BDD stands for Behavior-Driven Development. It's basically a full-stack agile methodology. And what that means is it's a complete process for doing software development that applies to all layers of your software stack. Basically, it's pulled a lot of good concepts out of a few different areas within the space. One is TDD, and it's taken a lot of the core principles and techniques that Kent Beck outlined in his book and his whole testing and theory around TDD and the process. It's also taken a lot from domain-driven design, which is kind of headed up by Eric Evans with a little help from Martin Fowler. And Martin Fowler also has been a pretty large contributor to the testing community as a whole. Other than that, it really is focused strongly around good object-oriented analysis and design at the core. So let's get going. So why BDD? I don't want to read through all of these. And I know there's some that people will say are probably controversial, like arguably faster development. Well, once you actually go through the learning curve and you actually get down the process, it really does end up saving you time because you usually understand and solve the problems up front while you're thinking about them rather than having built a bunch of software and then find out that you didn't think about something during that process and then have to go rework a bunch of stuff. So in my experience, it definitely has saved me lots of time, and it gives me a lot of confidence that my code is doing not only what I think it should be doing, but also solving the problem that we need to be solving for our business stakeholders, which we'll get into as one of the core principles later on. So let's keep going. All right, so what are the core primary principles centralized around BDD? Well, the biggest one, I think, in my opinion, is outside in. Everything in BDD is outside in. And the reason for this is largely that they believe if you design and develop things from the outside in perspective, you're taking into consideration the user experience and the domain that you're trying to solve problems in at the highest level. And they also require that you have a domain expert involved in this process. So the idea is if you talk about that with the domain experts at a high level, at the very outer limits, then you'll have a good idea at that level of what your requirements and contract you will have between the domain experts and your technical staff at that very outer level. Therefore, when you end up building something, you'll most likely be building something very close to what they want, if not exactly what they want. So beyond that, it also snags the concept of test first and very small iterative tests, as well as the whole concept of red-green refactor from TDD. And if you're not familiar with that, the whole concept of test first is basically you are required to write your tests before you ever write any code. And there's a number of reasons for that, which I don't really want to get into right now, but will be covered in later screencasts. The whole point in doing very small iterative tests is that you can get good isolation in terms of failures so that you can actually see what has failed when you're writing tests. Plus, it just scopes down the amount of code that you are required to test within those tests. Red-green refactor, the core concept is that you start with a failing test that is failing as you expect. And once you have that, you then go write the smallest amount of code possible to make that test go from a red state, which is failing, to a green state of successful. Once you have it in a green state, then you can move on to a next step, which is to refactor the code and to verify that after refactoring the code, it still passes green. And you basically, once you do the refactoring, if any necessary, you then end up going back to your test and moving on to the next step in evolving that test so that you're in an expected failure state again. Or if you've already iterated over that test and you really just need to add a new test on some object to verify the process, then you would have a new failing test and start the process over again by doing the red-green refactor. If any of that's confusing, because it probably is, it'll be covered in much more detail with prime examples in later screencasts. This is really just to give you a high-level overview. So the final core principle, which is actually a very important principle in BDD, is the concept of emergent design. And this is the concept that your tests really, especially in the case of test first, are what drives the design and architecture of your code. And basically the concept is, instead of you doing a huge amount of upfront design, what you do is you write your tests, and your tests drive the architecture and the objects and the classes that are existent in your code, and they slowly just evolve out of your tests, and as your tests drive you to refactor your code. So those are the core principles at a high level. If we start looking at the BDD test stack, the outermost layer of the BDD test stack is what are called acceptance tests. So acceptance tests are really a verification that the requirements of the contract between the technical staff and the business stakeholders have been met. Generally, this is composed of the following types of tests: black box testing, user acceptance testing, performance testing, but there are probably a few others that fit in that category as well. Really, you just need to think about this layer as verifying that the requirements of the contract between the technical staff and the business stakeholders has been met or not for given features. And that's the core concept of acceptance tests. So the next layer in the stack below acceptance testing is integration testing or full stack integration testing, to be more specific. So integration testing is the concept that you really are testing software pieces in a combined state. So basically this could be applicable at any layer of your software stack. It could be simply two methods interacting with each other. It could be two objects interacting with each other. Or it could be calling a method on an object really interacts with 5 methods on 2 other objects or 10 other objects. So an integration test at the heart of the definition is really just testing software pieces in a combined state. And you really need to start thinking about that and thinking about, when you're writing your tests, what components are going to be interacting, right? What do I care about actually testing, and do I care about testing the integration of these two objects, and what is that exact integration point? And more details of this will come in the future in further screencasts. So if we move on, the next layer down is non-full stack integration testing. So this is really the same concept that I just described in integration testing, but applied to the lower layers of your software stack. So this could be internal libraries that you use, or this could be models, or this could be integration between controllers and models. All of those different layers, just the core concept of having these tests that are really integration tests, which are testing the connections between multiple objects. So beyond integration testing, though, the next layer of tests that we have to deal with in BDD is what are called isolated integration tests. So isolated integration tests are something that is usually most valuable in terms of identifying exactly which integration point has failed. So in the case of integration tests or non-isolated integration tests, when the test fails, it could be failing because the thing that you're testing at the high level, or it could be failing because something 3 layers deep in your stack failed. And the reason that is because it's an integration test, right? You're actually testing from the highest level of your integration test all the way down however deep that software stack goes and however many different calls between different objects that test goes. In the case of isolated integration tests, what happens is you are testing an individual integration point. So for example, if you have a class A with a method and a class B with a method, and class A has a method foo, and foo calls class B's method bar, then there's going to be an explicit integration point of foo interacting with B's bar, right? So what you would do in that case is you would have the test centralized around that connection point, and any other connections to other objects or other methods would simply be stubbed out using a concept called stubbing or test doubles. And that is actually the portion of your test that is creating the isolation, basically isolating that singular integration point. And again, the value of this is that you are testing one explicit thing. So if that test fails, you know exactly what point failed. So if we continue on to the next layer of the stack, the next layer is isolated testing. So this is similar to isolated integration testing, except instead of using isolation to test a singular integration point, you're using isolation to test generally behavior or a small piece of behavior in a method, for example. And you would use stubbing, you would use object stubbing and method stubbing to actually isolate the other actions that are performed inside of that method to just test one singular piece of functionality within that method. And again, this has the same benefit as isolated integration tests in that your test is isolated. So if that test fails, you know explicitly that centralized piece of logic that you are testing within that method that's isolated is exactly what's failing. So you don't have to think about and debug like you do in an integration test. Well, what could actually be causing this is really 3 or 4 layers deep in your stack. So that's the huge value of isolated testing. So let's move on. And so the biggest point about BDD, as you can imagine, is BDD, since given its name, is all centralized around behavioral testing. So behavioral testing is kind of a testing style that most people aren't used to, who have seen unit testing. But behavioral testing is really just about testing the behavior of your code, as it says. I know that's a horrible definition because I just used the behavior word again, but really you can think about it in correspondence with what most people are used to, which is state-based testing. So state-based testing is much easier to explain. State-based testing is literally kind of the scenario where you have a given setup where it sets up an initial state of an object. Let's say you then call a method on that object, and that method alters the internal state of that object. And then after that, you would define an assertion based upon the state of that object. So what you're actually verifying is that given the initial state of the object is this, when I run this method, then I expect the end resultant state of this object to be XYZ, right? That's what people are mostly used to in terms of testing. And that's what people refer to as state-based testing. So one of the side effects of state-based testing is that it makes it very difficult to do isolated integration testing and isolated testing. It almost forces you to have to do integration testing in almost every case. There are a few ways around this, but most of them require you to drastically alter the architecture of your code to be able to provide any degree of isolation. So behavioral testing, on the other end, is verifying that the behavior of certain objects or function calls are performed, right? So instead of you providing an assertion that the end resultant state of your object is met, you are providing an assertion that a method is called on an object in a certain state. So that's the core concept. So for example, instead of you having an object A and given its initial state, you then call function foo, and that results in an end resultant state. Instead, you say, okay, given object A in initial state, and you say, when I call method foo, my expectation or my assertion is that inside of that, it calls bar, right? So you're verifying the behavior. You're verifying that when that method's called, given a given state, it performs this thing inside of it. It calls this method inside of it. And you're verifying the logic. The benefit of this at another level is that this really helps you identify when you're going from a pure test upfront perspective. This really helps you identify and flush out and kind of emerge the object-oriented design that's necessary for you to actually build out your functioning system. And it leads you down a refactoring path when necessary, generally. So the primary tools, there's two primary tools, and the first one that I'll talk about is the one used at the outermost layer, and that's Cucumber. Cucumber really depends on two core concepts, features and scenarios. A feature is basically a description of a feature, and scenarios are the different cases that you're testing or stating that should work at a business level. And those map directly to acceptance tests. So your features and scenarios are really a definition of your acceptance tests and the acceptance testing criteria. So this is something that you usually sit down with your business stakeholders initially, and you guys kind of go over these at a high level, and you, being the technical staff and the business stakeholder involved in your project, then discuss these and decide on what the core features are and what those important scenarios are. Oftentimes, you go back and as the technical staff, you flush these out a little bit more detail, but the business stakeholders always involved, and this is kind of like a centralized shared document expressing what the acceptance criteria are for your acceptance tests. So you may have noticed that there's another portion of Cucumber called step definitions. Step definitions are basically natural language mapping of your features and scenario steps to actual integration tests at a full stack level. And you'll see more of this when we get into some Cucumber examples and some further screencasts. But basically, you can see that this Cucumber basically allows your acceptance tests to double as full stack integration tests. And it keeps a living document that is defining your acceptance tests from a business level. And this guarantees, to some respect, if you actually follow the process properly, that you end up building and have built the correct elements in terms of what your task is from a business standpoint and a behavioral standpoint overall. So let's move on to the second tool. The second tool is RSpec. Now, RSpec covers all of the rest of the layers in the testing stack. It covers the integration testing, isolated integration testing, and isolated testing. And it can be used to do behavioral testing as is recommended and is the required process for doing BDD. But there are still a few cases every once in a blue moon where it does make more sense to do state-based testing, in my mind. And so RSpec very well allows you to do those as well. It does not hinder that in any way, shape, or form, but it definitely provides the capabilities and the abilities to let you do behavioral testing, which most frameworks do not. So, all right, on to the BDD cycle. So, as I mentioned before, it's largely centralized around red-green refactor, which is a TDD concept. So you can see in this diagram at the lower right corner where it says write a failing test, and then it has a red, green, and brown arrow, which is labeled refactor, and that's wrapped around TDD. Basically, this whole process is a nested red-green refactor. So what I mean by that is at the top level, you write a failing feature test using Cucumber, and once you have a failing feature test, you then drop down to the RSpec level, and the next highest level inside of your integration, your full stack integration tests, and you write a failing RSpec test there, and that fails, and you write the code that makes it pass. Then you refactor and so on and so forth. And then you jump back up after you've made that test pass to the Cucumber level, and you verify that that change actually made one step, for example, pass in your Cucumber scenario. Then you verify that it fails on the next step as you expect, and so forth. And you drop back down to RSpec, write another test that fails, then make it pass green, refactor, fail green, and so on and so forth. And this process continues over and over again. And this is the whole centralized idea around BDD, is that you take this TDD concept and you apply it at all the different levels of your software stack, and you use this process, which is hugely valuable to help you emerge a better, proper object-oriented design for your code. So that's it for this episode. I hope that gave you a high-level understanding of at least some of the components of BDD and how the test stack kind of looks, and a high-level understanding of where the tools sit. Next time we'll try to get into some details on different types of testing, and maybe I'm thinking about starting from the outside in, just for the sake of the fact that we're doing BDD, and maybe start with some acceptance tests and then move our way down the stack and so on. So see you in a bit.